Okay, Human Power Output Lab, boys and girls. Boys and girls. The Human Power Output Lab, the basic idea is that power is work over time. We're going to make our own formula. In this case, we're going to run up a set of stairs. So our work is going to be mgh, that is our change in potential energy, divided by time. And you can make your own formula. You could say that it's force times distance over time. You could say that it's 1 FmV squared over time. But the very best way to do this, I think, is to just have somebody run up a set of stairs. And that's what we're going to do. And if it's not bad outside, is it raining out right now? No. Beautiful. We could make a field trip and go to the concrete stadium stairs, the visitor's side. There. What?
Let's go there. Please, come on.
Such excitement. Okay. But anyway, we could make a field trip because that's the very best place to make this measurement, right? And so what we need to know is, of course, we need to know the height, the change in height of the stairs, right? Okay. And basically, we're going to have to go out there with meter sticks, and this will have to be a group effort. But there are many stairs. They're not all the same. We're going to have to add them together, right? And this is going to be something plus or minus. And then we have to make a guess. Guys, hello? Then we have to make a guess as to what our uncertainty is. And it's probably going to be something like half a meter or something like that. So we can pencil this in very finely, right? Probably 0.5 of a meter at least. By the time you've measured, because really the way to do this is like with like surveying instruments and stuff like that. We're going to use a meter stick, and there we have it, right? Everybody is going to do their very own mass, right? So the mass, there it is. And basically, there are two ways to do this mass, right? I know right now that my mass is, I'll bet that I'm 160 pounds, right? So I'm going to divide by 2.2, right? So take pounds, divide by 2.2. I bet I'm 160, and I bet I'm plus or minus about a kilo. 160, whoops. 160 divided by, whoops. 2.2. So that's like 70. I'm going to say 73. I'm going to say I'm 73 plus or minus. For sure, I'm within 2 kilos of that, and a kilo is 2.2 pounds. I'm sure of that. Okay. I haven't recently weighed as much as 168 pounds. I haven't recently weighed that much, right? If you ask a wrestler, by the way, wrestlers are going to say, at least in Iowa back in the day, they'd say, oh, I'm 132 pounds and 3 ounces, which is a really scary thing that they like know their weight, right? And then here's another weird thing that wrestlers will do is they'll drink some water and then they'll tell you how much more they weigh now. Are there any wrestlers in here? You guys don't worry about weight that much now, do you? People don't cut as much weight.
We still cut, yeah.
Yeah, but back in the day, like people cut a lot. Like my brother cut like almost 20 pounds. You know, he'd wrestle 132, but he'd normally weigh like 160 or something. I'd be like, oh, dude, how do you do that, right? And he did it by like dehydration. They would sprint stairs and wear like plastic suits and roll up in the wrestling mats and sweat, right? And then they'd wring out the long underwear they're wearing underneath that, right? It's like, he'd hallucinate the night before weigh-ins because he was so dehydrated. You know, I don't know. This is not a good thing. But anyway, how do we get on that? I don't know. Okay. But anyway, put your own mass. This is going to be your own weight. And the one way you could treat this is that if you really don't know how much you weigh, just guess. And then your uncertainty is your friend, right? So make your uncertainty, but make this all kilograms, right? The other thing you can do is I've got a scale here, but it's not a very good scale. I've got a scale here, and if you have no earthly idea, you can stand on this scale. Let's see what it thinks I weigh. We'll just see. It says I weigh 170, so it's guys like this scale. They're like, yeah, I thought I did, right? That might be somewhat accurate with all my clothes on. Okay, I'm thinking it's like a little heavy. Girls really don't like the scale so much. Kind of one of those scales, right? Okay, and then what you're going to do is you're going to have times for running. Okay, G is just 9.8. That's the one thing we don't really have to measure, right? You're going to have 4 times, 1, 2, 3, 4, okay? And those are your times. Everybody's going to have their very own 4 times for running up the stairs because this is your human power output. Now, let's suppose that you don't want to, like, you've got a bad knee and you don't want to, or you've got like sandals on, you don't really want to go sprinting up the stairs, okay? Feel free to just walk up the stairs, that's fine, okay? But if you want to like get a really high power output, obviously you're going to try to run up the stairs as fast as you can, okay? But don't kill yourself, don't trip and like knock your teeth out on the, oh, okay, here we have it, right? Okay, then what you're going to do is you're going to take these 4 numbers, and if you decide to run all 4 of them, right? If you decide to walk up all 4, right? And then you're going to average these guys, okay? Because averaging only makes sense if they're supposedly the same thing, right? And that's what we want to do, is average them, right? So this is the average time. I'll call this TAVG, right? That's the next thing down there, right? So obviously you're going to add them all up, divide by 4. That goes here, right? The sum over 4. What do you do for the plus or minus? Anybody know? Do you just like go high minus low over 2? Yeah? So find one of these. One of these will be the high one. One of these will be the low one. Just go high minus low divided by 2. Yeah? Maybe when we get inside, I could do it on the document camera. We could all go outside and do it and then bring it inside and I could show you. That sound like a good plan? Right? So just take the highest one of these minus the lowest one, divide by 2. That's your uncertainty for that, right? And then how do you figure out the maximum power you could have put out? Well, maximum power is going to be, you take this guy here, right? And you make all of these guys bigger in the numerator, right? So make the mass bigger. G is just G. Make the height as big as it could be. And divide by time. Make time as small as possible. Right, that'll be our maximum, and I'll show you how to do this. Okay? How do you make it as small as possible? Do the opposite. Make the numerator small, right? So M, make M small. G doesn't change. Make the height small. You didn't weigh as much. The height wasn't that big, and the time was really bigger than you thought, right? Okay. You can, by the way, for these times, just use the highest time. You could use the lowest time. You'll have 4 different times, right? So let's